In this video, I'll be showing you how to do machine learning on MATLAB. Now, why do I want to do it in MATLAB? Well, the reason is I'm an electrical engineer and we don't do much of Python in our undergraduate, and we don't even do a lot of machine learning algorithms in our undergraduate course. So I was tasked with my final year project on how to predict an axle failure. So we actually had an accelerometer placed in a truck's axle, which was giving it speed and vibration. So there were two sets of data which was given in a single CSV file. I'm pretty sure even in your project you would be given a CSV file and you would have to process it. Then in my case, I had to categorize. It was a classification machine learning, like that. I was doing the classification side. I did not do the regression one. So you might have a classification problem, then this script file will really help you. And I'll upload this in GitHub. So this is the one I'm going to be using um, on MATLAB. So that's my script file. And make sure that the CSV file is on the same directory. So this is the one, and we just go run section. Change folder. Yeah, I forgot to do that. Now it's going to run the whole code. I'm just going to close it, shut it down, because it's going to be a lot of information, and I don't want to really give all of it to you. So we're going to go by section. That's the format. I'm going to show you how I worked through this data set, what was going in my mind. I have done some extra bits on PCA, SVM with PCA, principal component analysis. SVM is a support of vector machines. Uh, I'm not going to cover it in this video, but I'll just explain it to you what it is. The code is still there and it's in GitHub. So if your supervisor or your lecturer wants you to implement PCA, which is called dimension, like it's just reducing dimensions. So I'm just going to cover it when we get there. But I'm not going to cover the speed side because it's exactly the same as the vibration one. So we're just going to focus on the vibration side, not the speed side. Um, and it's going to make a lot more sense when we get through it. Okay, so I think it should be done running by now. No, it's still running. Yeah, I've stopped it right now because it was taking too long. Okay, so now let's run through the code, right? Just wanna run this section. It's gonna clear all of the variables out. So the first thing you want to do is just read the data set inside MATLAB. And the data set is going to look like this. And like I said, it has two information. Well, those informations are divided by the way the row starts. If the row starts with a hash, it is vibration data set. If it starts with a diamond, a dollar sign, it is speed. So let's look for a diamond one, that's speed. This is latitude and longitude, and those are the speeds. And hash, I think this is g of x, g of y, g of z. So as you can see, you can either have vibration data or the speed data at the same time. This comes in handy for the next section we run. We look for the hash table, and wherever we see a hash, we make these columns, which is vibration, g of x, g of y, g of z. And naturally the speed at this time would be 0. And else, it just means that if you don't see a hash, just make sure that means that we have speed, then the speed data. So this is what it is, the date, time, latitude, longitude, and as you can see, this is it. So we run this section, even though I would be covering the speed data, but in my final year project, I had to do that. Okay, now the next thing is I have acceleration in some weird units, and I had to email someone, and then the guy's like, "Oh, you have to convert it to meter per second squared," and that's the formula to convert it in meter per second squared, and that's what we are doing, just making this, just scaling the data set, and we do that here. Now to just one thing which keeps on bugging me with MATLAB because I have started using Python now. In Python, they just make a data frame and that's it. In MATLAB, in my coding, I just have to do a lot of num to cell, cell to num. Just have to keep on playing with the arrays in MATLAB. Maybe you guys are better in MATLAB, but this worked for me. But I was doing this a lot, so I hope, I mean, I'm just making this clear. If there's another way, just put a comment down below. But I had to go num to cell, cell to num a few times just to make that. That's just a side note though. Okay, so now we've got the acceleration scaled, we are good. So now we just make two different tables. One's called vibration, one's called velocity. Naturally, we run this section and we just put the uh, elapsed time, event role, pitch, yaw, g of x, g of y, g of z. Um, Then we go to the next one. And in this one, what we have is, I just want the average acceleration, like just the average, just give me the average. And this is how you do the average acceleration, like of x, y, z. I just want one value and I just plot it. Now you can see that if you've got 71,000 rows and you plot something, the plot's not going to be that pretty. So what I did was I just divided the data up in 7,000 sections. So, and I just showed the plot. I just plot things just to make sure that I like the things are going right. That's that. You can see that 2.5 is the maximum point in most of them. It's not like I'm using this plot, but you know, just it just makes my supervisor happy. So I just did that. Then after this is once you've got all the plots, I want to naturally, it's a classification problem. So classification is if this is an apple or not. If this is category A, category B, category C, something like that. So what I do was, you can do something else. I just took the minimum average acceleration, then I took the mean acceleration, median, and max acceleration. That's it. I just took those values to classify my data. And in the next section, I okay, in the next section, I actually plotted again, I think, the average accelerations. Yeah, I'm doing that. So that's the average acceleration, the z acceleration, y and x acceleration. And in the next section, it's speed. Okay, so we skip the speed side. We add on this average acceleration into a vibration data set, and we then classify. Now our vibration data set is going to look a bit different. I'm just going to open it for you guys just to see. That's vibration, and look, the 10th column has all the things which we classified. So the classification side is done. Now comes the main beauty of this side. Yeah. Before that, I'll just show you what this side is. I'll just run this section. So what I'm doing is, okay, this is where you sort of have to listen a bit more carefully. These files on the left-hand side, this is generated by the MATLAB code. Now it depends on the version you have. I was running a 2017 one on my other computer. Uh, I have a 2019 one, but it's a student edition, so this one doesn't have that menu in classification learner. But this code, which you see over here, is generated automatically for you. You don't have to code anything to actually get these files out. Uh, I'll show you how it's done. But first, I'm just going to explain to you what am I doing over here in this script. So to train my model, I gave it 75% of the data set, 75% of 71,000 or 70,000. And then I just picked random values, random rows in the vibration test data set. And then I just wanted to save these values in the actual one. So I just want to save the vibration in row 55,000. What is it? What have I actually categorized it as? The actual one. And then I just want my model to take the same rows and then show me what acceleration it is predicting. So prediction underscore KNN should equal actual. That's what my main goal is. So what is actual? Actual is extreme, extreme, small, moderate, extreme, extreme. That's pretty good. And prediction underscore KNN is extreme, extreme, small, moderate, extreme, extreme. So this is what I want to do. And I did the same thing with the SVM. I think I get an even higher accuracy, so I get 100% accurate result uh, with this one. I think that was decision tree. And then I get this one. I think you can just play around this classification, and I'm calling on these files. If you look at this, this is the standard recipe to call on these files. I think SVM takes a while, but yeah, that's how I did this. Now to show you how you actually can do this, you just go apps over here. You go classification learner. Just wait for it. I think it's just still computing the SVM, and SVM takes a while. You just once you use these, you sort of start to know that SVM with big data sets, it's very slow. Decision tree and random forest, they love big data sets. But if a data set is linear, decision tree and random forest, they hate the data set. So that's that. And you saw that that's what SVM was running. So SVM is pretty slow with this data set. And I'll show it to you how to generate this code. So what do you want to do? I want to just take the vibration data set, and I want to do the holdout. Just give it 75% of the data. And I know that tree is the best one for this data set. I'm pretty sure if you have a large data set, tree will be really good for you, and random forests as well. And you can just go train. It's going to give you 100% accurate result in no time. And that's that. So that's how we sort of do it. So we get 100% accurate result. You can just go export model, and now there's a third one over here. If you don't have it, that's fine. You can just copy paste the code I have here and SVM, PCA on speed, and you can use these algorithms, classify underscore 100, I'm a classifier.m. Yeah, they would be, I'm not sure which one I am using over here. But you can use these classifier. If you don't have that, or you can just take, I think it depends on your university. I have to buy this for because I'm in a new course these days. So this is the education one, and the university one stopped working for me. But if you have that, that's going to make your life a lot easier, and then you can just copy the standard recipe on how to do that. Now, if you've got like a lot of rows, right, like a crazy amount of data, then you have to do something called PCA, which can come in handy for you. I have the code over here, but it's just going out of the scope of this tutorial. But what the thing is pretty much, I'll just show it to you. The way you do SVM with PCA, you sort of have to first normalize the data set, like all of it. I think I've done it somewhere here. For the vibration data set, or maybe in the end. Doing PCA on a data, yeah. So that's where it is. So the way this works is you first normalize the data set, and then you have to do PCA. And what PCA is, this is how I remember it. If you've got a 5 by 5 matrix and you multiply it by a 5 by 1, the inner dimensions should match, so you get a 5 by 1. So you've reduced this matrix from a 5 by 5 to a 5 by 1. So you need less memory to store this. And this is where eigenvectors and eigenvalues comes in place. Like I said, it depends on your application. Sometimes you might need it. In my case, I don't need it because my accuracy is high enough. But it's up to you, and that's what machine learning is all about. It's like a Swiss knife, and then you just have to keep on playing with the Swiss knife until you get the right one for whatever reasons you might need it for. So yeah, I hope this video really helps you. It's a lot of information, so I would just suggest like pause it and then go through it. by yourself, and then yeah, things will start making sense.